Okay, so yesterday we did learn how to solve two-step inequalities. Today we're still doing the exact same thing, but we're going to focus on also what it looks like on a number line. So let's recap a couple of things. One of the things I kind of stressed yesterday was I want to make sure as I'm solving these, when I get to my final answer, the variable has to be on the left. That's more than likely how they want it to be. When the variable's on the right, which means the letter on the right, then that's whenever I pancake it and I make sure the variable's on the left. That means flip the entire thing over, which we'll practice here in a second. Now, that being said, we got to remember some rules. When I multiply or divide by negative, which means if you remember from yesterday, if the number near the variable is negative, then I flip the inequality. That's the same thing as multiplying and dividing. What we're going to see differently today is what it looks like on a number line. So if the variable's on the left and its x is less than a number, it's going to be an open circle shaded to the left. If the variable's on the left and it's less than or equal to a number, it's a closed circle shaded to the left. Same thing for greater than. If its x is greater than a number, it's an open circle but shaded to the right. And then if it's greater than or equal to a number, then it's a closed circle shaded to the right. And one of the reasons why I stress the variable being on the left is if you did all your math correctly, your symbol is in the correct direction, it literally looks like an arrow which points the direction you're going to shade. So that's why the less than or equal to, I shade to the left. The greater than or equal to looks like an arrow pointed to the right. So that's when I shade to the right. So let's practice. If I look at number one, just like we've done since we started learning two-step equations, I see multiplication, I see addition. The opposite of addition is subtraction. So I'm going to do subtract 7. Since these are the same, I am going to add. So 41 plus 7 is 48. And I keep the same sign. So it's negative 48. Then I'm going to divide by 3. And since I'm dividing by a positive, or the number next to the variable is positive, I do not flip my inequality, so it's greater than or equal to, stays the same. A negative divided by a positive is a negative, so remember those rules. And 48 divided by 3 is negative 16. Now, my variable's on the left, so I do not have to pancake it, and let's go over what kind it is. If I look at my reference chart up here, greater than or equal to is a closed circle on negative 16 like that, and it's pointed to the right, so it's going to be shaded to the right because those are the numbers that are greater than negative 16. Then we continue. Next one, I see division, I see subtraction. The opposite of subtraction is addition. They are different, so I am actually going to subtract. 9 minus 7 is 2. 9 is bigger, so it's positive 2. Opposite of division is to multiply by 2. Multiply by 2 so that the 2's essentially cancel. Positive times a positive is a positive. 2 times 2 is 4. But here's the question. What did I multiply by? The number next to the variable is positive 2, so I do not flip the inequality. It stays greater than. This time, because it is greater than, it's an open circle. Anytime it doesn't have that equal to, it's an open circle. And if I did all my math correctly, it's pointed to the right, which means I shade to the right because those are numbers greater than 4. And then continue that process. I see multiplication, I see addition. The opposite of addition is subtraction. They are the same, so I am going to add those together. That is 45. Then they're both negative, so it stays negative. Then I'm going to divide by negative 5. I know some of you get in the habit of changing that. It's still negative 5. And then negative divided by negative is a positive. 45 divided by 5 is 9. But because the number next to the variable is negative, or because I divided by negative 5, I'm going to flip this inequality over to be greater than. So that changed a couple of things. Now, it's still an open circle because it's greater than, doesn't have the equal to. But because I flipped it, it's pointed to the right now, which means I'm going to shade to the right. And that's only because my variable is on the left. Okay, continue on. Do you remember what we do when a variable does not have a number in front of it? We put an invisible 1 there. The opposite of subtraction is addition, but this may be a trick one, so I have to double check. When I add 17, it does zero out negative 17, so I'm good. I always have to make sure it zeroes out. So it's negative 1x. They are different, so I'm going to subtract. 17 minus 15 is 2. 17 is bigger, so it's positive 2. Then I'm going to divide by negative 1. Then because 2 positive divided by negative is a negative, 2 divided by 1 is 2. Because the number next to the variable is negative, I am going to flip this, so it's going to be greater than or equal to. And since the variable's on the left, I do not have to pancake it. This time, because it has that equal to bar, it's going to be a closed circle on -2. And because I flipped it, it's going to be pointing to the right, which means greater than, so I'm going to go to the right. And that's it. We continue. Draw your line down the equal sign. I see subtraction, so I'm supposed to add, but when I add 10, it doesn't zero out positive 10. So I'm actually going to do the opposite and subtract 10. Bring down the -2x. 24 and -10 are different, so I do subtract. 24 minus 10 is 14. The opposite, or 24 is bigger, so it's positive 14. The opposite of multiplication is division, so I'm going to divide by -2. And the positive divided by negative is a negative. 14 divided by 2 is 7. But because the number next to the variable is negative, I'm going to flip this to be less than or equal to. Now, it's a closed circle because of the equal to. And because I flipped it, now it's pointing to the left, which means I'm going to shade to the left because those are the numbers less than -7. Let's practice a fraction one and the variable on the right. So if I look at it, the opposite of addition is subtraction, so I'm going to do -1. They are the same, so I'm going to add 11 plus 1 is 12, which stays negative. I'm going to bring down my -3/4c. Remember what we do when we see a fraction? I'm going to flip it and multiply. So I'm going to flip it to 4/3, still negative though. Okay, because a negative times a negative is a positive. Now, I simplify before I multiply. That means 12 and 3 can be simplified. 3 goes into 3 once. 3 goes into 12 4 times. So a negative times a negative is a positive. 4 times 4 is 16. And then 1 times 1 is just 1, which is 16/1, which is just 16. Now, I'm going to keep my variable on the right. That's important. Now, let's talk about the symbol. Since the number next to the variable was -3/4, I do flip this to be less than. But here's the kicker. Because the variable's on the right, I'm going to have to pancake it so that the variable's on the left. But when I pancake it, I also have to flip this inequality back because the mouth still needs to point to the C. So that's why it's like that. It is an open circle because it does not have that equal to bar. And since now, after all of that mess, I'm going to point to the right, which means shade to the right. And that's where it is. Then we continue. Opposite of addition is subtraction. Subtract 7. They are the same, so I am going to add. 7 plus 2 is 9, and it's -9. I'm going to divide by -9, and then negative divided by negative is a positive. 9 divided by 9 is 1. But because the number next to the variable is negative, I am going to flip that inequality. Now, I do not have to pancake this one because the variable is already on the left. So it's a closed circle because of the equal to. And since I did flip it, it's pointed to the right now, which means I shade to the right because those are the numbers greater than 1. Then I look at my next one. Opposite of subtraction is addition, so I'm going to add 7. They are different, so I am going to subtract. 7 minus 3 is 4. 7's bigger, so it's positive 4. The opposite of division is to multiply. So those essentially cancel. A positive times a negative is a negative. 4 times 6 is 24. Since the number next to the variable was negative, I do flip this. So it's less than or equal to. I do not have to pancake it because it is already on the left, the variable is. It is a closed circle because of that equal to. And because I did flip it, it's pointed to the left now. So that's less than because those are numbers less than 24. And then we continue. And we look at number 9, another fraction. I'm going to draw my line down the inequality. The opposite of addition is subtraction. Since they are different, I do subtract. 17 minus 13 is 4. 17 is bigger, so it's positive. Then 2/5 comes down. When I see a fraction, I'm going to flip it. So it's going to be 5/2, 5/2. Those crisscross applesauce. I do simplify 4 and 2. 2 goes into 4 twice. 2 goes into 2 once. 2 times 5 is 10 over 1, which is just 10. Now, the number next to the variable was positive, so that means I do not flip it, and it just stays less than. Since the variable is already on the left, I do not have to pancake it. It is an open circle shaded to the left because it's pointed that direction. Next one, opposite of subtraction is addition, so I'm going to add 17. They are different, so I'm going to subtract. 17 minus 1 is 16. 17 is bigger, so it's positive. And then I'm going to divide by 8. So positive divided by positive is a positive. 16 divided by 8 is 2. And then because the number next to the variable is positive, I do not flip my inequality. And so it stays that way. It's a closed circle though because of the equal to. And since it's pointed that direction, I shade to the left. Another one, I see addition, so I'm supposed to subtract. But if I subtract 9, then I don't zero out negative 9. So we're actually going to do the opposite and add 9. The 9's cancel. Negative 13 and positive 9 are different, so I do subtract. 13 minus 9 is 4, where negative 13 is bigger, so it's negative 4. I'm going to divide by 4. A negative divided by positive is a negative. 4 divided by 4 is 1. Since the number next to the variable is positive, I do not flip it, so it stays the same. It is an open circle on negative 1, and since it's pointed that direction to the left, I'm going to shade to the left. Last one up here. I'm going to subtract 14 because I see addition. They are different, so I am going to subtract. 14 minus 13 is 1. 14 is bigger, so it's negative. I'm going to multiply because the opposite of division is multiplication. Negative times a negative is a positive. 1 times 6 is 6. But the number next to the variable was negative, which means I'm going to flip that inequality. And so it is greater than. And then it's an open circle on 6, then shaded to the right because I flipped it. All right, last but not least, let's talk about solutions of inequalities. I'm going to show you 2 different ways to do this. One's more algebraic and the other is like what we've been doing. So let's practice what we've been doing. If I look at number 13, I draw my line down the inequality. The opposite of subtraction is addition, so I'm going to add 2. They are the same, so I am going to add 30 plus 2 is 32, and they're both positive, so it stays positive. The opposite of multiplication is division, so I'm going to divide by 4. 30 positive divided by positive is a positive. 32 divided by 4 is 8. Then because the number next to the variable is positive, I'm going to leave it, and m is less than or equal to 8. It is a closed circle on 8, so I'm going to shade to the left because I did not flip it. But let's pause there. Solutions of inequalities, you'll see questions like this is they want me to figure out which of these numbers are less than or equal to 8. Pretty basic, right? Less than 8 means smaller than 8, or on the number line, it means to the left of 8. Think about what numbers are left of 8. 7, 6, 5, 4, 3, all those negative numbers. So which of these are less than 8? Well, for sure, 6 and 7. But that equal to means also can be equal to 8. So that means 8 is also a solution. So those 3. 9 and 10 are not because they would go to the right of 8, which we want to the left of 8. And that's it. Let's do another one. The opposite of a subtraction should be addition, but if I try to add 4, it's not going to zero out the 4, so I'm actually going to subtract. I'm going to bring down that negative 4 in. Since they're different, I am going to subtract. 16 minus 4 is 12. 16 is bigger, so it's positive 12. Then I'm going to divide by negative 4. And positive divided by negative is a negative. 12 divided by 4 is 3. Now, because the number next to the variable was negative, I do flip this, so it's going to be greater than or equal to. That would normally mean a closed circle on negative 3 and shaded to the right. So this time, I got to find out which of these are greater than negative 3 or to the right of negative 3 on a number line. This is the trick part because it's a negative. If you think about a number line, negative 3 next to negative 3 on the right would be negative 2, then negative 1, then 0, then 1, 2, 3. On the left would be negative 4, negative 5, negative 6. So which of these are actually to the right of negative 3? But it's confusing because we think bigger. So it means smaller. So the only one that's really bigger or smaller than negative 3 would be negative 2. Those would be to the right. Now, this closed circle or this equal to bar means equal to negative 3. Well, the only number equal to negative 3 is negative 3. So my answer are those 2. Now let me show you how I could do this algebraically. If you remember PEMDAS back in 6th grade, this is where that comes in handy. Again, it's a little more tiresome because it's more work, but I'm just going to show you anyway. Where if I want to just not worry about solving like this, I can substitute these numbers in for A and see which ones would be greater than 8. So for instance, if I substitute negative 8 in for A right there, I would have 8 less than negative 2 minus 2, parentheses, negative 8. That means multiplication. Well, 2 times negative 8 is negative 16. And then when I have subtracting a negative, I'm going to treat it as addition because you do keep, change, change. And then it would be negative 2 plus 16, which is 14. And then if I look at it, 14 is greater than 8, or 8 is less than 14. So that is a solution. If I did that all again, but this time with 7, or negative 7, then 2 times negative 7 is negative 14. When I do minus negative 14, it would be addition. And negative 2 plus 14 would be positive 12, which would also be greater than 8. And then if I did the same thing with negative 6, again, it's kind of just like trial and error. It would be negative 12, which would be minus negative 12, which would be addition. Negative 2 plus 12 is positive 10, which is also greater. And then I continue again, doing it again with negative 5. So it's a little more work involved because it's trying each individual one. That would be negative 10, which would be, 8. Now here's where it's the difference. 8 is not less than 8. It's equal to 8, but not less than 8. So negative 5 wouldn't be a possibility. Now, I also know negative 4 wouldn't be because this number would be also smaller, so it would not be greater than 8. Now, again, that's just one way to do it. Truth be told, great if you want to. I'm just more in strategic as far as like solving for it and then figuring that out. So if I try number 16 the way I showed you up here, I'm going to draw my line down that inequality. The opposite of division or addition is to subtract. So I'm going to do minus 4. Since they're the same, I'm going to add. 4 plus 1 is 5. Keep the same sign, so it's negative. The opposite of division is to multiply by 2. Multiply by 2. So negative times a positive is negative. 5 times 2 is 10. Since the number next to the variable is positive, I'm going to keep it greater than or equal to. So then it's a closed circle on negative 10. It's pointed to the right, so that would be shaded to the right. And I have to be careful here because I have to think of numbers on a number line. So you really have to imagine a number line. That would be to the right of negative 10. That would mean negative 9, negative 8, negative 7, and so on. The numbers to the left of negative 10 would be negative 11, negative 12, negative 13. So the only numbers on my list that would be either equal to negative 10 or to the right of negative 10 would be negative 10, negative 9, negative 8, negative 7. The only one that wouldn't be would be negative 11. Same thing here. Opposite of subtraction is addition, so I'm going to add 16. They are different, so I'm going to subtract. 16 minus 13 is 3. 16 is bigger, so it's positive. Earlier we saw a fraction question. When it has a fraction, I'm going to flip it and multiply. Flip it and multiply. So then they crisscross. Notice my variable's on the right, so I'm going to keep it there. I do not need to simplify here because it's just 1 and 1. So 4 times 3 is 12. Since I multiplied by a positive, since the number next to the variable is a positive, I do not flip this. Now, my answer is not quite done yet because I have to pancake it to where the variable's on the left. So if I pancake it, the entire thing flips over. It has to be like a mirror image, okay? Because now I flipped it, it's going to be closed circle on 12. And since I flipped it this way, it's pointed to the left, which means I'm going to shade to the left. Now, I have to think about which numbers would be to the left of 12 on the number line. Think of 11, 10, 9, 8, 7, and not to the right. Well, also because of the closed circle, it can be equal to 12, which means on my list, 12, 11, 10, and 9 are possibilities. Last one. I see subtraction, so I'm supposed to add, but when I add 10, 10 plus 10 is not 0. So I'm actually going to have to subtract 10. So I have negative 3m. 61 and 10 are different, so I do subtract. 61 minus 10 is 50. 61 is bigger, so I'm going to keep it, 51. 61's bigger, so it's positive 51. Then I'm going to divide by negative 3. And positive divided by negative is a negative. It's 51 divided by 3. Got to do some ice cream here. Is 17. And because the number next to the variable is negative, I do flip it. So it's going to be greater than. I do not need to pancake this one because the variable is already on the left. So it's an open circle, negative 17. pointed to the right, so I shade to the right. Now here's where you got to be careful with negatives. Technically, numbers to the right of negative 17 look like they're getting smaller. Negative 16, negative 15, negative 14, negative 13. Numbers to the left are getting bigger because negatives work differently. Now then I have to think about which one's on my list. Here's the kicker. Negative 17 is not an answer because it doesn't have the equal to. So because it doesn't have the equal to, negative 17 is not an answer. But everything else to the right of negative 17 would be. So that's it.